Hello students, myself Harsh Gupta and today I am going to teach you about quadratic equation. So before knowing quadratic equation, you should know about the polynomial. An expression in the form of px is equal to a0 plus a1x plus a2x square plus dot dot an x to the power n is called polynomial of n degree. But a polynomial whose degree is 2 is called quadratic equation. The standard form of the quadratic equation is ax square plus bx plus c is equal to 0, where a, b and c are the real numbers and are called coefficients, where a not equal to 0. Suppose if a becomes 0, then if a becomes 0, the term x square becomes 0, bx plus c is only left here, and which is a linear equation. Now, the roots of the quadratic equation. Roots are basically the solutions of the quadratic equation. The value of the unknown variable which satisfies our given equation is called the roots of the quadratic equation. Example, x square minus 5x plus 6 is equal to 0 is given quadratic equation. Now, on putting the value of x is 2, we get 4 minus 10 plus 6 is equal to 0, and then putting the value of 3, we get 9 minus 15 plus 6 is equal to 0, means x equal to 2 and 3 satisfies our given equation. It is called the roots of the given quadratic equation. Now, quadratic formula. Quadratic formula are used to find the roots of the quadratic equation. This formula also known as Sridharacharya formula. See, if our quadratic equation is ax square plus bx plus c is equal to 0, then x is equal to minus b plus minus root b upon 2a, where b is the coefficient of x, a is the coefficient of x square, and b is called the discriminant, where d is the discriminant and d is equal to b square minus 4ac. Now, nature of the roots. Nature of root described by discriminant d. If d is greater than 0, then our roots are real and distinct. If d is equal to 0, then our roots are real and equal. It means our quadratic equation have perfect square. For d is less than 0, we have complex and conjugate roots. Now, relation between roots and coefficient. Let ax square plus bx plus c is equal to 0 be our quadratic equation, and alpha and beta be the roots of the given quadratic equation. Then, the sum of the roots alpha plus beta is equal to minus b by a, and the product of the roots alpha into beta is equal to c by a, and the mod of the difference of the roots is equal to root b by mod a. To obtain the quadratic equation for the given roots, we have the formula x square minus sx plus b is equal to 0, where s is the sum of the roots and p is the product of the roots. Let alpha and beta be the roots of our given quadratic equation, then our quadratic equation will be x square minus alpha plus beta into x plus alpha into beta is equal to 0. Now, let's come to a question. If alpha not equal to beta and alpha square is equal to 5 alpha minus 3, comma, beta square is equal to 5 beta minus 3, then the equation whose roots are alpha by beta and beta by alpha. We have to find the equation whose roots are alpha by beta and beta by alpha. As we see clearly in this question, alpha and beta are the roots of the quadratic equation x square minus 5x plus 3 is equal to 0, because alpha square minus 5 alpha plus 3 is equal to 0, alpha satisfies this equation. Also, beta satisfies the same equation. Therefore, alpha and beta are the roots of the equation x square minus 5x plus 3 is equal to 0. Now here alpha into beta is equal to c by 8 means 3 by 1 is equal to 3. Alpha plus beta is equal to minus 5 by 1 means 5. Now we have to find the equation x square minus of product sum of the roots alpha upon beta plus beta upon alpha into x plus alpha by beta into beta by alpha means 1 is equal to 0. And now alpha by beta plus beta by alpha is equal to alpha square plus beta square with LCM alpha into beta. And now alpha square plus beta square, we can write here alpha plus beta whole square minus 2 into alpha beta upon alpha into beta. Here alpha plus beta is equal to 5 and its square becomes 25 minus 2 into alpha beta. 2 into alpha beta means 6 upon alpha into beta means 3. Now it becomes 19 upon 3. Now putting this value here, we get our equation x square minus 19 upon 3x plus 1 is equal to 0. On simplifying this, we get 3x square minus 19x plus 3 is equal to 0. This is our required answer. Now come to our next question. Find k such that x square plus 2 minus k into x plus k minus 2 by 4 becomes complete square. Yes, we have to find the value of k for which our given equation becomes a complete square. So students, let's think when we get complete square. We get complete square only when discriminant becomes 0. Now, if we want to find the value of k, we have to show that the discriminant of this equation is 0. Means b is equal to 0. b square minus 4ac is equal to 0. And b here is 2 minus k means 2 minus k whole square minus 4 into a into c is equal to 0. On solving this, we have 4 plus k square minus 4k minus, on multiplying minus 4 in this bracket, minus 4k plus 2 is equal to 0. Now on simplifying, we have k square minus 8k plus 6 is equal to 0. We cannot solve this equation by midterm splitting. We have to use the quadratic formula here. K is equal to minus b plus minus root b upon 2a means 8 plus minus root 8 square minus 4 into 1 into 6 upon 2 into 1. We have 8 plus minus root 64 minus 24 upon 2. 8 plus minus root 40 upon 2. On solving this, we get k is equal to 4 plus minus